In this video, we're going to do an introduction to limits. We're going to look at finding limits by a graph and a table. So I have this picture of a rainbow here, and we all know that there's a pot of gold at the end of the rainbow, but if we were to follow the rainbow, we never actually would quite get to this pot of gold, and that's kind of the concept of limit. We're going to get as close as we possibly can, but we can't actually get there. So we're going to look at different things throughout the year, like rectangles. We're going to try to make rectangles, and we're going to try to make them thinner and thinner and thinner. And eventually, we can't really have a rectangle that has a width of 0. So since we can't actually get there, we're going to get as close as we can, but we're not actually going to get to a width of 0. So that's kind of an idea for a limit. So, what is a limit? This is the technical definition of a limit. It's kind of confusing. So the basics are that a limit is a y value we're getting really close to as we get really close to some x value. So your answer is a y value, and we're looking really, really, really close to some x without actually getting there. So sometimes we'll look at a function that approaches different y values from both the left and the right. So that would be something that would be a piecewise function. Maybe it looks like this, and up here maybe it looks like that. So as we come in from the right and as we come in from the left, it approaches two different y values. We can't just pick our favorite, so in that case the limit would not exist. What we can do, however, is look at just a right-hand limit or just a left-hand limit. So the notation for that is if we see we have a little plus sign here or a little minus. So plus means from the right. So as we're coming in from the right, what y value are we getting really close to? Our left-hand limit is what happens as we come in from the left. What y value are we getting really, really close to? If the limit exists, they have to approach the same value. So when there's no plus or minus, that means we're just looking for the overall limit. In order for that to exist, they have to be exactly the same. If we see a little plus or minus here, that means we're only looking in one direction. If there's nothing here, that means we're looking in both directions. So our notation, it's kind of already been up here. We read this as the limit of the function f of x as x approaches c is equal to L. And this is going to be our y value. One thing to pay close attention to is the symbols here. This does not say x equals c. We're not going to get there. We're going to get really, really close to that value. It's like our rainbow. We're never actually going to get there, and we don't want to get there. We really don't. So, when finding a limit, again, we're looking for the y value the function is approaching. We are not looking what happens when we get there. So in this particular picture here, we have a graph. If we were to find the limit as x approaches 0, we're looking right on this line, because that's when x equals 0. Right on that line, the function is not defined. If you notice here, there's an open circle. That is okay. That means it doesn't exist at x equals 0. This arrow says we're not getting to x equals 0. We're getting close to 0. So we're going to get infinitely close on the left and infinitely close on the right. And whatever that y value is, in this case 2, is our limit. Okay? So different ways to find limits. Make a table. This is a lot of work. Draw a graph. If we already have a graph, this is really nice. And use algebra. This is going to be kind of the most common method that we use. If we're looking at a table, here we have a table of values. If we were using this same problem and we had a table, again, this says we're going towards 0. That means we have to come in from the right and from the left, and we're trying to figure out what y value are we getting really, really close to. So you can see here we're getting really close to 2. Here we're also getting really close to 2, so that's our limit. we can't put that right here because in a table, these are function values. We don't want this value. We want to know what to get really, really, really close to. So sometimes the limit fails to exist. Here, this is a jump. This is like a piecewise function. So again, as we come in from the right, we approach 1. From the left, we approach -1. Those are not the same, so the limit does not exist. However, the limit as x approaches 0 from the right would exist. That would equal 1. So one-sided limits will exist in most cases, but the overall limit in this case doesn't exist. If there is a vertical asymptote, the limit does not exist. What we will do in a couple videos from now, we will describe what it does do. So we'll say, because this goes up forever and ever and ever, we'll say the limit is infinity. Now, infinity is not really a number, so by saying that, we're also saying that it does not exist. And we'll get to that later. And then finally, we won't look at any examples of this, but if a function oscillates, meaning it goes up here an infinite amount of times, the limit will not exist either. So we're just going to do an example by looking at a graph. All of these are overall limits. None of these are one-sided limits, so our limits have to match. Again, none of these say x equals, so we're never going to look when x equals that value. So, for example A, it says, what happens as we get really, really close to -3? -3 is here. I do not care that there's an open circle there. That means nothing. I just want to get really close. From the left, I get really close to 3. From the right, I also get really close to 3. So 3 is my limit. Part B says, let's look now as we get really, really close to 0. Again, it doesn't matter that this is open or closed. I just want to get really, really, really close to 0. So here I'm approaching 3. Here I'm also approaching y equals 3. For part C, x is approaching -2. So here now we're looking at this line. As I get close from the left, I approach a y value of 1. As I approach from the right, I also have a y value of 1. As x approaches 1, again, that open circle means nothing. I don't want to get there. I don't want x to equal 1. I want to get really, really close to 1. So as I come in on the left and the right, both of those are approaching y equals 2. So that's my limit. And finally, for part E, we're going to look as x is approaching -1. As I come in, I'm getting closer to this line. Again, I don't care about this closed circle or this open circle. As I come in from the left, I'm approaching 1. And as I come in from the right, I'm approaching 2. I cannot just pick my favorite. So here I would say this does not exist.